Hi guys, so I'm going to make a video on some sample computations with cohomology and derived categories that will be kind of useful. Okay, so I'm just going to, so this is derived categories part 2. Alright, everything looks like it's in focus. So let me just start. So here's something to consider, first example to consider. Okay, so we're going to take a complex, okay, and suppose that each of the maps are the zero map. Okay, so this is a degenerate complex. So here in this complex, so here's so this is the ith piece here. So here Hj, well, this is going to be the cocycles modulo coboundaries, right? And so you can see that here Kj, sorry, this part here is, so the kernel is going to be the whole thing. So the top is this, and then the image of the previous map is going to be 0. So this is just Kj. So so this is a complex with a 0 map. This says complexes with 0 maps are have pieces isomorphic to their own cohomology. Okay, okay, let me give you a definition. Okay, so let's take a complex K. Okay, and then we form, so this a new complex. Okay, so here I'm just gonna put the 0 map. Okay, I'm gonna put the 0 map on everything. So here we just have a complex, right, where we have 0 maps everywhere, and so this is what I'm gonna mean by H bullet K. Okay, I'm gonna take a cochain complex with 0 maps. And then in this case, we have when we have a complex, we can take cohomology, and then we have that that the cohomology of the complex is clearly the cohomology of this trivial complex. Okay. Okay, so we have this complex like this, and we have this isomorphism. Okay, so one question we can ask, so we saw what derived we saw in derived categories that we had morphisms of complexes, and that they were isomorphisms in this category if they induced quasi-isomorphisms, meaning that the cohomologies were going to be identical. So in this situation, we can ask, here's a question. So again, so what was the definition here? The definition was of this complex here, this cohomology complex with the 0 maps. Okay, so that's all I defined. Maybe it's a notation. So one of the questions that you can ask is, when is the isomorphism star induced by an isomorphism between K and H bullet K in the derived category? And let's say we're working over an abelian category A like as before. Okay, and okay, so I guess from yeah, we'll just say in the derived category. I guess we don't need to specify. I was going to put a plus here and say that we were only going to consider complexes which eventually vanish at the negative values, negative integers, so the ki's would be 0. But I mean, this isn't necessary right now to impose this. But I mean, later we want to restrict to those things, because because this is what's going to be relevant to our applications. All right. So now we can move on. So that's on my list of things to do. Okay, so now I want to show you how to embed a category into its into its derived category. So if we take an abelian category, we're going to be able to stick it into its derived category. So definition. So a complex concentrated at 0 okay, is one that looks like the following: ... 0, and then we have a single object A, 0, and then ... Okay, so and this is the degree 0 piece of the complex. Okay, so this is a complex concentrated at 0 in the abelian category A. Okay, so so let me give you a fact. So there's a embedding of A. So there exists an embedding of A into the derived category of A via well, what happens is we take an object in A, and then we'll map it to this this complex concentrated at 0. So this is in the derived category of A, and so okay, so we just take it to this stupid cochain complex. Okay, so from now on, convention. Okay, so from now on, we will identify objects of A with their complex concentrated at 0. Okay, so this is kind of nice. So this will come up, and so when we want to talk about something being equivalent to something in the derived category, an object being equivalent to something else in the derived category, for example, its injective resolution, which we'll see in a second, that this is what we mean. We mean that it's equivalent to this complex. Okay, so we use our derived category definitions to do this. Okay, so we have our stupid complex. Let's make a observation. Okay, so here are just, I guess, a number of observations. Okay, so let's take K to be a complex. So this is a complex, cochain complex. Okay, so we have H0 of K. Okay, and this is a stupid complex. So this is a stupid complex. Okay, but what I mean by that is this is so this is in degree 0 here, this piece. So we just take its cohomology, and then we identify. So this is the complex concentrated at 0, like we had before. Okay, so concentrated in degree 0, and now we have okay. So we have K. I guess we can have K minus 1 here. Okay, so now, now I'm actually gonna, we need to not have K minus 1 here. Here, K1, so in D plus of K. Okay, so these things here, let me make, so these are, so here, complexes need to have, let's say that ki is equal to 0 for I less than 0. Okay? So this is a definition here. Okay, so they're positive complexes, non-negative complexes. Okay? So we have this, K1, okay? And, okay, so we have this stupid complex here. We have this complex here. This is zeros, since we took it into being D+. Okay? And so there's a map here, and there's a map here. So we're going to actually have a morphism here, and we actually have an embedding of this into this. So notice that this thing here, so this is the kernel of this map here. That's all it is. So this is just the kernel, the usual kernel inclusion. Okay, so we always have H0 of K bullet 0 into K bullet in, oh sorry, A, dang it. Okay. So that's that. That's all I wanted to say about that. Okay, so let me give you a definition. So this is a non-standard definition, but I'm going to need it for the linear Z stuff. So a simple complex. So is here we're just going to say that it's concentrated in degrees 0 and 1. So that means that it's so it looks like this, 0, K0, this is the degree 0 piece, K1. So it's a complex of the form like this, 0, and then it goes on with zeros everywhere. So this is i.e. concentrated in degree 0 or and 1. Okay, so I'm just going to do some basic computations with simple complexes. Okay. So some basic computations. Okay, so here we can let's take a simple complex, 0, so A, B, 0, and we have a map F here. So we just have like a morphism, right? And then we're going to just look at a complex here like this. Okay, and then I'm going to extend by zeros all the way out, but I'm not going to write that. Okay, so this is going to be the degree 0 piece here. So this is important that we know what this is, okay? And so we can ask what H0 is of something like this. Okay? And so this doesn't really have to do with derived categories. It's just a basic thing about cochain complexes. This is Z0 divided by B0. Okay? So this is the kernel of this map, right? So this is the kernel of this map divided by the image of this map. So this is just the kernel of F. Okay, similarly, we can just do some other basic computations for a simple complex, or a complex concentrated in degrees 0 and 1. So it's just a morphism again. Here, I'm not writing the zeros all the way, the dot dot dots, but we understand that this is degree 0, this is infinite, and then it goes out. Okay, so this is Z1 modulo B1. Z1 is the kernel of this map, right? So the kernel of this map is, well, that's all of this. And B1 is the image of this map. Okay, so when you take the B1, B modulo the image of this, so this is equal to B modulo the image of F. And so this is just the co-kernel of F. Okay, so for these simple complexes, you just have kernels and co-kernels. Okay. Another thing to say is that there's another observation that we have is that we have that A, so let's say B goes surjects onto H1 of this complex here. So, well, okay. So for a simple complex, we have surjections like this. All right. Okay, so so this is for simple complexes. So truncations. So let me talk about truncations real quick. Okay, so given a complex K, okay, so this is, you know, this could be anything. So Ki, sorry, dot, dot, dot. So not necessarily having only positive terms or non-negative terms. Ki plus 1, dot, dot, dot. So this is, maybe we view it in this is a cochain complex. Okay, it's a cochain complex. I'm not going to say what category it's in. Okay, so we don't need to view it in the derived category or anything. It's just stupid. Stupid complex. I mean, we're not even looking at morphisms. Okay, so what we can do is we can define a new complex. The truncation of K here. Okay, so we take our complex and we truncate it. Oh, I need to specify. So this is tau less than or equal to, and let's say n. Okay, and so what it does is it copies everything up to k. So we go up to n. So we go to n minus 1, and then we have kn, and then then it's 0 from then on out. Okay, so all it does is it just truncates. It does exactly what you think it would do. It's stupid. Okay, and we can check that these truncations that they just do, you know, what we expect stupidly. Okay, so like tau less than or equal to n of k. Okay, so it's the same thing, right? If we don't go up to n, strictly less than n, and then it's going to be kn for I is equal to n. Let's see if that's right. So this is Zn. Zn's the whole thing. So sorry, this is Kn modulo the image of Kn minus 1. Okay. And then here, this is 0 for I bigger than or bigger than n. Okay? So we just have this. Okay, so this is just stupid. It's almost the same. And then here we have a co-kernel. Okay. All right. So another operation is this shifting operation. So shifting operation. Okay, so there's a shifting operation, and so what we can do is we can take a complex, a cochain complex, okay, and and then what we can do is we can shift it, right? So so this kj is equal to the one shifted to the left by j, i.e. kj at I is equal to k of I plus j. Okay, and then we have the d's are just as we had before. Okay, so now okay, so the claim is that h I of kj is equal to, okay, so I've omitted bullets again, but that's okay. So this is, we're just going to sometimes omit bullets, and we're going to be okay with that. Okay, so this is the stupid complex, right, of k and then shifted at j. Okay, so so this is the stupid complex that I defined earlier, and we can do this. Okay, so this is an inequality. So the proof of this is really easy. I mean, this is an exercise, but I'll just write it out. So we're just going to take it easy. So hi of kj is equal to zi of kj modulo bi of kj. This thing here is just the kernel of kj I to kj I plus 1. And the bottom part is the image of kj I minus 1 to kj I. Okay, and now we're just going to put in our definitions here. So the top part is just the kernel of ki plus j, and this is ki plus j plus 1. This part here is the image of ki plus j minus 1, ki plus j. Okay, so I'll call this star, and then I'm going to continue on to the next page. So this is equal to, this star here, so this was equal to, well, we had the kernel of the I plus j, so this is zi plus j of k bullet, modulo j, bi plus j of k bullet, which is just hi plus j of k bullet. Okay, so this proves, which proves our result, which proves what we wanted to show. So it's just something silly. So this justifies this notation that's used in, there's a notation that's used sometimes in papers, and in particular the Lin-Lu-Z paper, that hi, k, let's say j, and then they could pick another letter, L, like this. So like here, there's two ways to do the parentheses. You could do the parentheses around the cohomology, or you could do the parentheses so you could do one here, or you could do parentheses here. Okay, and it doesn't matter. So the parentheses not needed. Not needed. Okay, so you could make a notation like this if you wanted to for I, J, and L. Okay. Okay, and remember that, okay, so this is this, and another thing that we could say is that, so in the same thing, that this is H bullet, so as complexes we have this, bullet K shifted, okay? So I guess this is the same thing, so not only as terms, but as complexes. So these two complexes are the same as complexes. As complexes with 0 D map. All right. Okay, so now, so that's some basic computations for cochain complexes.